Hello everyone, in this video we are going to see how to do a real-time gripper control with the pyrobotiqgripper Python package. So let's get started. So in this new version of the pyrobotiqgripper package, there is a function called realTimeMove. This function is made to be called at high frequency. Actually, you are asking the gripper to go at a certain position. So it's a position request that is sent at high frequency. And there are several features to be able to have a smooth control of the gripper, even if we ask the gripper to change its target at a quite high frequency. So one feature first to save the communication bandwidth that we have with the gripper is that we don't send twice the same command. So there is a kind of filter that prevents this from happening. Then also there is a feature where there is a minimal motion parameter. If we request a position that is very close from the current position, the gripper will not take this request. He will not move. This is to prevent some effect where the gripper may check around, start to check around the position. For example, if you have a joystick, you can easily move from one byte to another, like you can be between 2 bytes. The gripper then get this information and can go like byte 3 by 4, byte 3 by 4, byte 3 by 4, and it starts shaking. So it make not so nice motion. So to prevent this kind of shaking effect, so we have a minimal motion parameter in the function. So yeah, if we send a position request that is close from the current position, the gripper will not move, will not take the request. So then we have a variable speed. So the way it works is that so if the gripper, if we ask a position that is close to the current position, the gripper will go very slow to this position to make a smooth motion. If the request position that we send is far from the actual position, the gripper will go at high speed toward this position. And as soon as it goes closer, the speed decreases. So that's how works this function. So you don't precise the speed when you send a position request. Actually, the function will automatically set the speed depending of the distance between the actual position and the targeted position. So the profile of the speed, the evolution of the speed can be changed using some parameters called minimum speed position delta and maximum speed position delta. So here you see the speed profile. In X, you see the distance between current position and the target, and in Y, this is the speed that is applied for the motion. So you can play on this profile using those parameters. The default parameters works quite well. There is another feature here. This is the secure grip. So actually, when we make small motion, so where we ask position request close to the current position, so the gripper will move very slowly to ensure to have a very smooth motion. But if at this speed, if you catch an object, actually the gripping force will be very low. So if you grip on an object with a zero speed and zero force, you will have a very low grip on the object. So there is a feature in this function where if the gripper detects an object at slow speed, it will automatically secure this object by closing on the object at full speed and full force. So like this, you are sure to always have a good grip on the part. And one feature that we have also on this function is if you ask the maximum opening or the maximum closing, the gripper will go there at full speed and full force. So we assume that the gripper assume that if you ask a position 0 or a position 255, the gripper so expect that think that you want to close on an object, so it go full speed, full force. Let's check the documentation of this. So you can see in the documentation the different parameters. So the first parameter that you can give to the function, so this is the position request. So this is the position you feed to the gripper at high frequency. Then there is the minimum speed position delta and maximum speed position delta. This is to change the speed profile of the gripper. So to change the speed depending of the distance between the current position and the target. The continuous grip, so this is an option. Actually, if it's true, the force is set to 1. So if the gripper has a force of 1, it will always try to make a further closing toward the object. If the force is 0, the gripper just stop at the position where it detects the object, and if he will not try to close further. By default, the force is set to 1. I believe it's good to leave it at 1 to always secure an object, but you have the possibility to put the force at 0 if you want. The autolog function, so this is a function we spoke previously. With this function, so the gripper will close at full speed and full force if it detects an object. So there is possibility to deactivate this function. The minimal motion, so this is the minimal distance that you need to have between the current position and the target to have the position request sent to the gripper. There is a variables argument also. So if you set it to 1, you will see all commands that are actually sent to the gripper. And if you set it to 2, you will see a command and also status retrieval information that will be displayed on the terminal. So this function is made to be called at high frequency for real-time control of the gripper. And here in the documentation, you have an example of loop using a pygame and a joystick. So we retrieve the position of the joystick at high frequency, and we feed this joystick position to the gripper through the realTimeMove function. To demonstrate the realTimeMove function, an application is available to test it. It's called pyrobotiqgripper joystick. So we are going to use this function to demonstrate how works real-time move function. First, we are going to display the help. So there are several parameters you can pass to this function. And so the help tells you what are the different arguments you can pass. So actually, what we are going now to do is, so we will just probably leave the default parameters, but you can set the joystick ID. If you want to control the gripper with a joystick, you can set the joystick ID here. By default is 0. This is the first joystick connected to the PC. You can also set the axis of the joystick you want to use to control the gripper. Default is 3, and then you can set all the parameters of the real time move function. We just set it to default. One thing that we will do is that we will set the verbose to 1, just for you to see the communication that is sent to the gripper. So let's press enter. So the connection is done with the gripper. The gripper has been found on CAM 8. Activation is performed. The activation procedure for the real-time function is a bit longer than the normal one, because we calibrate the speed also of the gripper. It's something that we need to make the real-time control. So I'm now controlling the gripper with the joystick like this. The joystick have a quite low resolution, so it's not perfect to control in real time. But you can see that the motion is quite smooth, and I can see on my screen the different commands that are sent to the gripper. So to better see how smooth is the motion with this function, we are going to use a specific option. So it's possible to control the gripper opening and closing with the mouse actually. So if you put the mouse cursor at the left side of the screen, it will make a full opening. If you move the mouse cursor on the right side of the screen, it will make a full opening. So like this, we have a very fine control of the gripper. So it's nice to demonstrate the real-time control capability. So to control with the mouse, you need to set the joystick ID to -1, like this. So now the gripper connection is happening. It calibrates the speed. Okay, and now you can see that I can, with my mouse like this, moving left and right, control the opening of the gripper. I can ask full close, full opening, have quick motion between two very distant target, and very small gentle motion for little motion like this. So this time we are going to do the exact same thing, but the gripper is connected on a remote PC. So we are going to control the gripper in real time using the RTU via TCP method. So there will be something like this. So we call the application. We keep the verbose at 1 to see the communication message. For the joystick ID, we'll go with -1, so we control the gripper with the mouse. And the communication type is RTU via TCP. the remote PC IP is 10.0.0.153 and the TCP port is 2000. So on the remote PC, so the remote PC is now tunneling the gripper connection to the Ethernet. So I'm going to connect to the gripper from my PC. So the activation happened, and then the speed, the gripper calibrated speed. So now with the mouse I can control the gripper, but this time the gripper is not connected to my PC,